Alrighty guys, it's test review time. Alright, so first one, if this outside angle is 158, then these two inside angles had better add up to be 158. Hashtag exterior angle theorem. So if I want to figure out the missing one, I can do 158 minus 67, and that would give me 91 degrees. Over here, actually, let's go in order. Number 2, find the measure of angle x. Find x if the measure of angle 2 is x plus 47. Alright, this is 52, and I see these markings, so that means that the angles across from those have to be the same. So this guy's 52 as well. The right angle box means the total here is 90, so angle 2 is going to be equal to 90 minus 52, which is 38. So that x plus 47 better be equal to 38. I'm going to get a negative answer for x, but that's okay. Let's see. So 38 minus 47, x is negative 9. Moving on. Numero tres. I see these markings. That means that the two angles across from those those legs must be the same. So x plus 92 equals 180. If I do 180 minus 92, I get 88. And then I'm going to have to divide that 88 evenly amongst those two x's. So x equals 44. And number 4, find x and list the sides in order from greatest to least. Whoa. Alright, so first of all, I know that all three of those angles added together will be 180 degrees. Alright, so math. Let's see, 42 plus 62 minus 2. Got to combine all my like terms. That's 102, so I've got 26x and 102 after I combine my like terms. I'll subtract 102 from 180. 26x equals 78, and then divide by 26 and get that x equals 3. So that's first part taken care of. If x is 3 though, then angle C is going to be 26 times 3 minus 2, or 76 degrees. If I'm listing the sides in order from greatest to least, I'm going to have to start by finding, okay, the greatest angle is 76. That means the greatest side is across from it, AB. The medium angle is 62, so the medium side is across from it, AC. And the smallest angle is 42, smallest side is across from it, BC. Alrighty, back up to the top. Number 5. Scroll. Ooh, alrighty. If this is 44 and this is 63, and the total in the first triangle is 180, I need to see what's left first. So 180 minus 44, and then minus 63, puts me at, let's see, 44 plus 63, puts me at 73. And the three angles under this little arch make a line, and therefore 180 degrees. So if I do 180 minus that 73, and then minus 67, I get 40 left over. And then if this is 40 and this is 110, together those two are 150 right there, and that makes 30 what's left over. Find the measure of find x given that the measure of angle 2 is x plus 59. See these marks? That means that I have sides that are the same. So if this angle is x plus 59, so is this one. And you can solve this in a couple different ways. What I would probably do is recognize that if this angle is 80, then the two angles left over would add to be 100. So angle 2 and this guy over here are going to be 100 together. But since they're both the same, I could set each one equal to 50 and then solve. So x would equal negative 9. Number 7, find the measure of angle C. Okay, so I've got exterior angle theorem going on. I've got this outside guy equal to the sum of the other two remote interior angles. Let's combine some like terms. 11 and 17 is 28 x's. Positive 2 and negative 1 is positive 1. Whoop, I'm skipping a step. 85 minus 1 is 84. And then I'll divide by 28 to see what x is. 84 divided by 28 is 3. That's not the question, though. The question says, what is the measure of angle C? So instead of putting an x, I'm going to put a 3 instead. So 17 times 3 minus 1. Do that in my calculator really quick. 17 times 3 minus 1 gives me 50. And number 8, solve for x. I notice that these angles are marked the same, meaning that the sides across from those angles must be the same. So I'm not actually going to even use that 2x minus 4 in my problem. I'm just going to set 7x minus 10 equal to 3x plus 6. And then subtract 3x from both sides, add 10 to both sides, and then divide. Hiya! Classify each triangle by their sides and angles. If all the sides are the same and all the angles are the same, angles being the same means equiangular, and then sides being the same means equilateral. Here, all of the angles are different. But this one's 90 degrees, so it's a right triangle. But since all the sides are different, it's a scalene triangle. Number 10, find the value of x. The diagram is not to scale. Well, let's see. So first of all, I'm noticing this little section and this little section are the same, making that dot a midpoint. This little section and this little section are the same, making that dot a midpoint. So the line here in the middle is a mid-segment, which I know to be half as big as this longer side. So if this guy's 32, this guy's going to be 2 times that, or 64. Moving on. B is the midpoint of AC. I'll mark that. D is the midpoint of CE. I'll mark that. AE is 10x minus 8, and BD is 2x plus 2. Find x and BD. The diagram's not scale. Alright, so like we saw above, this one in the middle, the mid-segment, is going to be half the size of the one down at the bottom. So if I take 2x plus, 2x plus 2, or 2 of these sizes of BD, then that would be 10x minus 8. Alright, distributive property. And combine like terms. Decimal. Let me check my work. So 2 of these equals that. Oh, guys, crazy town happening. 2 times 2 is 4. and then that would make this 12, and then x is 2. Alright, so found x, and now I need to find BD, and I'll just plug 2 in everywhere I see an x. So 2 times 2 plus 2 is 6. That's the length of BD. Alright, back on up. Points B, D, and F are midpoints of the sides AE of triangle AECE. EC, let's see, this is a midpoint, this is a midpoint, and this is a midpoint. EC, so this whole guy is 30. And DF, so from here to here, is 23. Find AC. Ooh, diagram is not scale. I don't really even need to know this 30, I don't think. If I've got all these mid segments and this part is 23, then each of these two guys across from it are going to be 23. Or AC is going to be twice as big as FD. 23 times 2 is 46. So sometimes they'll give you information that you don't necessarily even need. That EC would help me figure out that, like, oh, this is 15, and this is 15, and this is 15, but not really helpful in terms of answering the question. Find the length of the midsegment, draw diagrams not to scale. All right, midsegment. This 4x plus 2 is half the size of 4x plus 44. So again, it's not that they're equal to each other, but this big one is 2 of the little ones. Distributive property. And subtract 4x from both sides, and subtract 4 from both sides. So x is 10. Find the length of the midsegment. So they want to know how long this guy is. I'll have to take 10 and substitute it in. 4 times 10 is 40, plus 2 is 42. So this is my final answer. Find x and y. Alright, if I see these markings, I see an isosceles triangle, so the sides across from those congruent sides will be the same. Y will be 65. And if 180 degrees are in the triangle, if I do 180 minus 65 and then minus 65 again, I see that x is going to be the 50 degrees that are left over. Ooh, here is an equilateral triangle. All the sides are the same, so it's also equiangular. All the angles are the same. I'll set each of those equal to 60. So y equals 15, and then x plus 20 equals 60, so x equals 40. Again, these are equiangular, so all the sides have to be the same. Ooh, I don't think there's enough information to solve this one. We can set up an equation. Ooh, yes I can. I can solve it. I'll just have to set up two equations. All these sides are the same. This one's 24, so 2x better also be 24. So x is 12. All the sides are the same, so each one's going to be 24. 24 is equal to 3y, so y equals 8. Which statement can you conclude is true from the given information? AB is an altitude. Ooh, altitudes, I think of mountains measuring straight down, so I know this is going to be a right angle at, IAJ is a right angle. That's up here, so it's not that one. AJ is the same as BJ, not necessarily true. IJ is equal to JK. An altitude. I don't think we can assume any of those. We would be able to pick some if this was like a perpendicular bisector. If this was maybe reordered as IJA, that would be true then. But the way it's written, I think this is just kind of a typo in here. All right, number 16, fill in the blank with the appropriate segment. So name an angle bisector. Angle bisectors cut angles in half. So over here I see some angles being cut in half. The thing that's cutting in half is CE. Name an altitude. Altitudes make right angles and you measure straight down. So AF looks like an altitude to me. And a median cuts, our road in half. So I think about that. Where I see that happening is over here with BD. If D is the midpoint of AC, then BD is what kind of segment? Median. Sicily. Alright, number 17. Given right triangle ABC with B equal to 3x plus 10 and A equal to x, C is the right angle, what is the value of x? You could draw a picture to kind of help you figure this out, but I know that a right triangle, just like any triangle, will have all three angles add to be 180. C is the right angle, it's 90. A is x, and B is 3x plus 10. Another way you might have set this up is like, oh, right angle's already taking up 90, so the other two angles will be 90. Either way is totally cool. And then it's just some algebra. Subtract 10 from both sides, combine like terms, and then divide. So x equals 20. Find the value of A and B. Ugh. Okay. So if this is 40 and the whole thing over here is 90, that guy right there will be 50. 50, 66, and then B is going to have to be whatever's left. So if I do 180 minus 66, and then minus 50, I get that B is 64. And then there's a couple ways that you could find angle A. You could think about like the big triangle has 64, 90, and then A, and then just do 180 minus 90 minus 64 and see what's left. Other thing you could do is recognize that right here I have a straight line. So 66 and whatever this angle is would be 180 together. If I do 180 minus 66, I get that this angle is 114. And then I have 114, 40, and A that have to equal 180 together. I could write out an equation like that to talk about that triangle right there. Alright, so 180 minus 114, and then minus 40, I get 26 for A. Alright, and find the measure of angle B. Ooh, exterior angle theorem. That outside angle, 6x plus 10, is going to be equal to my two remote interiors added together. And then I will combine some like terms. And solve for x. Number 20. Solve for the variables. I've got a bunch of triangles here. I'm going to want to start with the one where I know the most information. The first triangle has two things missing, whereas the second triangle over here with the 32 and the 46 only has one thing missing, x. I know that together that 32 and that 46 and the x make 180. So if I do 180 minus 46 and minus 32, and see what's left, I would find that angle x is 102. X and y together make a straight line. So if I do 180 minus 102, I would get that y is 78. And then finally, 78 and 36 together is 114. And then if I do 180 minus those two together, then I'll figure out what's left, and that would be 66 degrees. And we found them all. Okay. Scary. I might begin by finding out what y is, just by knowing that 3y plus 141 is 180. 180 minus 141 is 39. So y equals 13. And a couple things you could do. You could plug back in and recognize, okay, this angle's 39, plus 68 gives me 81, and then if I do 180 minus that 81 and find out what's left, I would have 99 for x. The other thing you could do is recognize with the exterior angle theorem that x plus 68 should be equal to 141, this outside angle. So this is the exterior angle theorem. And again, 141 minus 68 will still give me the same answer. Hang on a second. I messed up somewhere. 39 plus 68. Oh, this guy shouldn't be 99. This guy should be 73. There we go. Fixed it. Okay. Two more on this page. Let's see. Well, 130 and the 2x make a line together. So 130 plus 2x equals 180. So 2x equals 50, and therefore x equals 25. Cool. And then same thing with exterior angle theorem. 130 should be what I get from the two remote interiors added together. 130 minus 54 is 76. And then dividing by 4, I get that y is 19. And finally, I have three interior angles, and I would know that if I add them up, I should get 180. Alrighty, so we'll combine some like terms. 2x, negative 3 and positive 8 gives me 5, plus 45 gives me 50. 180 minus that 50 gives me 130. And then if I do 130 divided by 2, I get that x is 65. Last page. Yep, just a couple more. Solve for x. I see a mid-segment. So that means that the guy in the middle, the x plus 5, is going to be half as big as 3x minus 9, or 2x plus 5 gives me 3x minus 9. Distributive property. And then combine like terms. And I would get that x is 19. Ooh, solve for x. This looks gross. Alright, so I see a perpendicular bisector that comes down, and I know with perpendicular bisectors, I end up making like a side angle side, like congruent triangle kind of phenomenon. So that 3x and that 5x minus 9 are going to be equal. And if I put the 9 over here, subtract 3x, that gives me 2x equals 9. So x is 4.5, 22. On 23, once again, I've got, let's see, an angle bisector, and I have two right angles, and by angle, angle, side, the one they have in common, I would know that these triangles are congruent, and therefore 6x plus 4 is going to be equal to 8x minus 6. I'll combine some like terms and get that x is 5. Is AQ a perpendicular bisector or an altitude? Explain. It looks like an altitude to me because it's measuring the height from A down to the bottom, and bisectors have to cut stuff in half, and CQ and QB are not the same. So this is just an altitude. Is RB a median or an angle bisector? Angle bisector because I see these angles being cut into two equal pieces, and no markings over where the sides are being cut. What kind of segment is CP? CP is a median because it's cutting these this side in half, and it originates from a vertex. List the angles of PQR from smallest to largest. Alright, here's the small side, so P is the small angle. Here's the medium side, so that means R is the medium angle. And here's the large side, making Q the large angle. Let's try it again. So here's the small side, making Q the small angle. Here's the medium side, making P the medium angle, and large side makes R the large angle. Next, we've got to list the sides from longest to shortest. I'll need to figure out this missing angle by doing 180 minus 59 and then minus 61. So this angle is 60. And if I want the longest side, I'm going to start from the largest angle. So the longest side is DF. Medium would be across from the medium angle. So the medium side is DE. And then the small side will be across from my small angle. So that would make EF.